Okay, so what is ionic bonding? Well, ionic bonding means that there is a transfer of electrons between atoms. And so one atom, for instance, might give up an electron and give it to another atom. So this atom we would say, loses an electron. Sometimes it's more than one. And so this atom gains an electron, sometimes more than one, and electrons are negatively charged. So if you move a negatively charged particle from one atom to another, then this atom becomes more negative, and we now call it an ion. And what's left behind is more positive, so that too becomes an ion. These happen to be called cations because we positively love cats, and these are negative or anions. So positive cations, negative anions. And so there's been a transfer of negative electrons resulting in ions, which is why we call it ionic bonding, because opposites will attract, and that's what the bond is really all about. So atoms, we already talked about how atoms in the table in groups 1 through 7 are going to want to barter electrons to achieve something close to this state, full or 8 electrons in their outer shell. And when atoms in groups 1 or 2 get together with atoms in groups 6 or 7, then you tend to see this transfer of electrons. And so the example you probably are getting is sodium, which has atomic number 1, and chlorine, which has atomic number 17. So sodium will have a nucleus with 11 protons, and then it will have the first shell, which can keep up to 2 electrons. It's pretty small. And then it will have the second electron. We can put 8 more in there. So we've used up 10 of the 11. And the last shell will have only 1 electron in it. And of course, sodium is looking for 8 electrons in whatever shell it used last. So sodium is desperately unhappy. And sodium has a choice. Either it can get rid of 1 electron, or it gains 7. And getting rid of 1 electron, of course, will be much easier for sodium. So chlorine, meanwhile, has 17 protons in the nucleus. And so we're going to fill up the shell. Notice that it too is neutral, so there's no charge. So that means we have 17 protons, which are positive, meaning 17 electrons, which are negative, balancing out the charges. So I'm now putting 17 electrons in the shells. So here's the, let's make this the first shell. So 2 electrons used up. I can put 8 more over here. So I've used up 10. And now I'm going to go 1, 2, 3, 4, 5, 6, 7. So chlorine, too, is very unhappy. It too is looking for 8 electrons in whichever shell is being used last. And so it has a choice. It can either get rid of 1, 2, 3, 4, 5, 6, 7 and find some poor atom to take all 7, but that's not so likely to happen. And so instead, it'll probably try to gain 1 more electron. And so this is a match made in heaven. When sodium meets chlorine, then sodium says, aha, how about I give you this electron? So we're moving a negative charge. And sodium now ends up with 8 electrons in its outer shell. So it's happy. When we get rid of this one, chlorine ends up with 8 electrons, so it's happy. And when sodium gives up this electron, it too has an outer shell with 8 electrons in it, so it is happy. Because we are moving negative charges, sodium becomes positively charged and chlorine becomes negatively charged. Opposites attract, they're bonded.